the hidden performance cost, I forgot that word existed, of Node.js and GraphQL. Okay, so Node.js and GraphQL are popular technologies for building web applications, but in my experience, they come at a certain scaling and performance trade-offs to be aware of. Wait, hold on. I thought Bun made JavaScript faster than Rust. So what's this thing he's talking about? Incorrect take? Bad take? GraphQL's modular structure generally leads to code that instantiates excessive promises, which degrades request performance. Benchmarks show as much as 2 to 3x latency increase. Yeah. Yes. About 3 weeks ago, I tweeted that promises are actually really bad for performance. Okay, Node.js is known for its non-blocking I/O operations. Yeah, that's what everyone keeps telling me. If you say something like this to the modern JavaScript engineer, if you say the phrase, don't use a promise, you will literally get people to be like, you mean you're going to write sync code? Isn't that slower? And it's just shocking that there's not a middle ground like, oh, you mean you want me to handle this without using, you want me to do async without promises? It doesn't exist in the brain at this point. It's shocking. All right, all synchronous work in Node.js happens over an event loop thread. Other than a few isolated multi-threaded features like worker threads and, of course, garbage collection largely happens async. If you read the, what is it, Oriocho? What's the name of it? Oriocho? Something, O-R-O, something is the name of their sweet garbage collector. It's awesome. With the event loop is managed well, and the I/O is a true bottleneck. Node.js can be very efficient / scalable technology. In general, JavaScript is very efficient if it doesn't have to do a lot. It's like your classic way to fix things. If JavaScript isn't doing a lot, then of course it's pretty fast. What would be async without promises in JavaScript? A callback. This may be hard to comprehend, but taking out a few promises and going back through the event loop can actually really help. People forget about continuation passing style. People forgot about I know it's. Are callbacks really async if your date never does them? Shut up! Oh my goodness. On the other hand, if a request does a lot of processing on the event loop, it will block other requests on that container. Node.js applications are particularly susceptible to sporadic performance issues due to noisy neighbors. A lot of the sporadic performance issues actually typically come from garbage collection. Other heavy request handlers that overlay consume the event loop. Additional GraphQL's resolve, like if you run on a single core. So if your instance is single core, yeah, concerned about performance, don't use Node.js. It's really that simple. But if your instance runs on a single core, you get massively hampered by garbage collection. Right? A garbage collection is so efficient these days because it can run on more than one thread. Additional, GraphQL's resolver structure can result in more promises overhead compared to REST endpoints, which may cause suboptimal user-perceived latency if not managed carefully. Fair. GraphQL... Oh no, it's that thing. Here, continue reading. Just let a man read. GraphQL enables a modular design for APIs. For example, we define a type in our schema and define one resolver for that type, regardless of where that resolver appears in the graph. User, query the user. This modular design is great for developer experience, but leads to promise-heavy code. Okay, yes, we know. Each promise adds a minuscule but non-zero amount of work for the event loop, which is discussed here. To demonstrate, let's say we want to write a feature that retrieves a user's item. That retrieves a user's items. Wow, so many S's right there. On a shopping site, we might build a REST endpoint like this. User items details. This would be powered by a few SQL queries. Get some user, get this. Typically, maybe we would do a join. I always say we should just write SQL instead of using an ORM. I might be mistaken. A well-structured REST endpoint would have some relatively simple code that makes these database queries and massages the data back into a desired format. We would have no more than a few promises involved and resolve in the request lifecycle. In GraphQL, we would encourage to write a query like this: user, items, ID, details, item, other fields. If we have a if we have it well-structured as GraphQL resolvers, we might have type resolvers for users and item details. Yep. By the way, this is called creating a chatty protocol, by the way. So for those that don't know chatty protocols, it's where you start making a bunch of small requests to something else. And so chatty protocols tend to have like a distributive degrading performance problem, right? Because obviously making one small request, not a big deal. Not chatty, not with a D, chatty, right? Not giga chatty. No, no one would say that unless if your protocol is very chatty. When executed, a GraphQL query with nested fields will result in a promise per field being created, such as user, get user, item, user and items, const ID, other fields, get item by details. Oof. As we use data loaders to prevent the n+1 query problem, this would translate to the same squeal queries as we described in REST endpoint case. So the I/O cost would be as optimized as possible, but we would create one promise per item in the loop, and each promise adds work to the event loop. A promise per field is pretty crazy. The funniest thing I've seen with GraphQL is the fact that it ultimately ends up as JS API common queries commands. If we only had something like that, if only we had some sort of structured language in which we could make queries with. That's really what I think people want. You know, structured queries. Language. I'd be squealing for it. SLQ? Oh, yeah. Let's call it SLQ, Structured Language Query. I like it. I like this. TJ, we're on to something. You know a lot about language servers. We could develop one together. I've written a benchmark of GraphQL server that returns user to demonstrate the impact. The overhead increases as we increase the number of promises involved. We choose two GraphQL servers, Apollo Server plus Express and a Mercurius. Oh, I'm so curious. Mercurius, they call me Mercurius. By the way, Express is actually the worst framework ever created. Like, I understand it was the first, but Express is so bad at performance. It is shocking how bad Express is. Like, Express just doing basic requests, not a hot take. There's nothing hot about that take. It's crazy. My innovation would be that instead of putting select before from, you'd put it after from, and squeal and Sloweek would be so. Oh, dude, it'd be so Craigasm. From this field, select that out. I do agree. That actually is the superior way. Are you saying that Express is not Express at all, dude? It's not. It's not. Express is absolute doo-doo. And I'm not saying that the people who invented Express are doo-doo. I'm just saying the performance that has been created in Express is doo-doo, okay? Because it is. It just is. All right, the benchmarked queries return the same data, but one wraps every field response in a promise, and the other returns data synchronously. We return 100 items per user. Number of users returned, sync user milliseconds, okay? Data loaders plus promises. Okay, I'd like to investigate this more because I've done some playing around with this and it can be really bad. This is very interesting though. Like, look at this. That's pretty wild. This is pretty wild. Mercurius. Oh, I'm so Mercurius. Okay. I mean, again, I never trust other people's benchmark numbers, but I think there's at least something to be said that it's much, much larger, right? That maybe it's not good. Maybe it's not great, but this shows that there's a huge disparity and that there's probably a big problem there. We see that wrapping each user and item in a promise causes 2 to 3 increase in request latency. An invalid criticism here is that real-world GraphQL resolvers perform I/O, so the overhead will reduce significantly as a percentage of time taken by the resolver. A well-tuned database can perform 2 squeal queries to return 10K items in less than 100 milliseconds. You could just do one, baby, which is reasonable, small percentage of high. Okay, I'm actually a little stuck on that whole 2 squeal thing. I'm really stuck on that. I'm going to let it go. Everybody, we're letting it go together. Everybody in chat say, can we just all quote, is it Elsa? Can we all quote Elsa right now and just let it go? Let's just let it go. Let it go. Jarut. All right. An invalid criticism here is that the real-world GraphQL resolvers perform I/O so that the overhead will reduce significantly as a percentage of time taken by the resolver. A well-tuned database can perform 2 squeal queries to return 10K items in less than 100 milliseconds, which is all of this doesn't make any sense. Like, this phrase doesn't make any sense in general, right? Which is a reasonable small percentage of high latency caused by the GraphQL server here, regardless of Express or Mercurius. Real-world code is even messier. We might check feature flags or perform other async work in a resolver, which further increases the number of promises the event loop has to process. All right, so can I give you a quick reason, one reason why the event loop can be a little bit difficult and people don't really understand why it's bad? Can I give you a quick little understanding of it? Let's just talk about this. So the event loop, how it effectively works, looks something like this. Okay, let's go like this. Let's pull this thing out. Oh gosh, I'm no master at XCaliDraw, but we're okay at it. All right, so the event loop does something like this, right? It looks a little something like this, where it pulls next task off queue and check micro task queue, right? Or empty micro task queue. So you can starve your threads by having this. So if you have a bunch of micro tasks or things that run right away, you can kind of starve yourself, right? And so you get, you know, it can be bad. It's a loop, if one would say. Now, what does the task queue look like? Well, every time you do something like set timeout, what will happen is that there's a linked list that exists somewhere. And every time there's a set timeout, it does this, right? It adds an item to the list. So let's say that let's go like this. I'm going to put 4 items in here, right? We're going to put 4 little items in here. There we go. And let's say that you are this item and you are the first to be executing, okay? You get this beautiful chance to be executing, and the rest of you are going to be red items, all right? And let's say that you are going to do a promise, and this promise actually resolves synchronous cached work, okay? So all you do inside of your little promise is you have like a little async func that checks for some sort of cached value. Cached value, like, you know, if cached, return, right? You get the cached value, it returns it back out. Pretty simple. So what that means is that when you do this, you go check your cached value. All right, you got a cached value, return it. Well, what's going to happen? Promises resolve next tick. So this guy's going to be, let's see, let's go like this. Let's take this guy. Let's take him off. The next time you get to run is now at the back of the queue. So now this person's going to run. This one's going to run. This one's going to run. And then now you're going to run again, and you're going to have another chance. That's how that's how the event loops work. And so what ends up happening is really simple items like this. You throw an async on a function that doesn't need to be async. Guess what? It actually is. It will run significantly slower because you could have a bunch of people in line ahead of you, a ton of people. They can't resolve in the like immediate queue. If they resolve in the immediate queue, you could starve yourself. You could sit there and just starve yourself over and over and over and over again. And so a callback, right? Like, so if you use a callback to know when, say, you write out to, transactions stay open too. Yep, it's going to stay open for a while. So if you use like a callback to write a file to disk, or you use a promise, what you get is when the thing is done, right? When writing a file is done, it calls the callback. That callback is called synchronously, right? So it stays. You maintain owning the process event loop for the duration of that callback. So you do your extra work, and then you write more to a file. And until that file comes back, you're not going to be called. But once it's done, it's called back, and then you now are at the back of the queue, and once you hit it, then you can start using again. So this is the big inefficiencies with this stuff, right? Because if each one of these takes, say, very little time, a half millisecond, whatever, right? Each one of these takes a half millisecond, but there's also another half millisecond in between each one of these to be called to the next one, or whatever it is, a quarter millisecond, whatever it's going to be. You could add in an extra, 3, 4, 7 milliseconds of just lag. And so every single process, every single time you go back to the process tick, it happens again, it happens again, it happens again, it happens again. And so this is why you can all of a sudden get these huge amounts of latencies, is because you just happen to keep going to the back of this queue over and over and over and over again. So, understand some things. Understand why these things can happen, because it is really important. It can really add a bunch of stuff. Hey, Indifferent Ghost, how you doing? All right, let's diagnose the problem. It's useful to diagnose this problem in certain operations. First, we should confirm that our application is actually blocked on the event loop. Node.js exposes a handful of perf hooks to measure event loop utilization. Oh, I didn't know how much of this is true. I haven't played with any. I haven't played with their. I didn't realize that Node.js offers some hooks for that. That'd be kind of fun to play with. I'm gonna have to play with that. Next, we should confirm that our event loop isn't blocked by code we control. In my case, I confirmed this by inspecting CPU profiles. If the event loop is occupied for more than 50 milliseconds with no obvious culprit in sight, the culprit is likely in the runtime. Okay, fair. Next, we can confirm how promise-heavy our code is through the following code snippet. Each GraphQL operation should increase the number of promises created and give us a clue how promise-heavy is our code. All right, so we're going to do a little async hooks. Hooks, create hook, init, something, type promise, count plus, hook enabled. Oh, interesting. I didn't realize you could do async hooks like that. That's kind of interesting. Another practical approach to determine whether the event loop is a blocker is determining the difference between client-reported database query latency and database-reported query latency. For example, I mean, this is actually a very true source, right? If you can query a database and you get certain latency, then you query your application and you get very different latency, you got some things you can at least make some judgment about. Obviously, the hard part is where are you located? Where's the database located? Where's the database located in comparison to your application versus where you're located at? You have to take a lot of those things in. For example, I noticed that the client-side reporting of certain database queries is often greater than or less than 100 milliseconds. No, greater than 100 milliseconds, sorry. Even though we were making an index query with a table with less than 1,000 rows. As expected, we couldn't replicate such a slow performance when manually querying our database. This slowdown was because the event loop was overwhelmed after making database requests. So even though the database responded to certain requests very quickly, the web application did not get around to processing the responses until after a significant delay. If you've forgotten why there's a significant delay, remember the graph that I showed you. And remember, every single time an await happens, it does it once. Every single time a dot then happens, it does it once. So if you dot then, you will have 3 going back to the back of the line operations. Since async await only affects request throughput in certain promise-heavy conditions, or most open source code is not heavily optimized to prevent unnecessary promises. This example, GraphQL Shield, is one of the most popular GraphQL auth libraries. Assumed every field resolver is async. Therefore, it constructs a promise for every field in the GraphQL response, which further amplifies the number of promises created in this lifecycle of a request. That's crazy! It's crazy! TypeScript and JavaScript do not prevent developers from unnecessary marking functions as async. Yes. This is true. So we need ESLint rules like require await to avoid unnecessary async await calls. Dude, I literally found a performance problem in some code, and I kid you not, it was because a function was marked as async that was not async. It increases garbage collection. It increases time it takes. Right? It's actually a real problem. It's wild. Yeah, exactly. Promise explosion equals memory explosion, which equals more GC interrupts. Dude, it's wild. An accidental, unneeded async function can add milliseconds to response times, which means, I mean, think about how many async functions you could go over, right? All right, APM and promises, actions per minute. Everyone's favorite thing, us StarCrafters. Finally, we can incredibly slow down promise execution if we use async hooks, a deprecated but widely used Node.js feature. Async hooks help us track asynchronous resources. For example, a tracing library might desire to track a request across callbacks and promises. Unfortunately, any code we import may rely on this feature and can auto-enable it. ddtrace, Datadog's APM library, and likely many others, uses this feature to provide traces across promise executions. Oof. When your tracking library slows down your entire universe, that's not good. This makes me want to join Marvin Hagemeist and start optimizing open source libraries. It would be it's a pretty big win. The thing is that often a program's not slowed down by a single issue, right? Oh, by the way, that's my favorite tweet, which is I'm gonna tweet that. I'm gonna tweet this. It triggers everybody, which is my favorite thing. It's like my favorite kind of tweet is the one that nobody wins. Let's do this. Nobody wins here. Nobody wins. Boom. Post it. Oh my goodness, it's Annie. If you don't know Annie, you don't know shit about Twitter, okay? You don't know shit about Twitter. I've tweeted this a few times, some version of this. Oh man, it's the greatest. Oh, it's the greatest. People lose it. People lose it. All right, anyways, fantastic. Async with hooks, yep. None of this is surprising. Obviously, adding tracing to anything you do asynchronously, of course, by its very nature, is going to cause a huge slowdown. What is this Twitter? It's the place you go to. So when you go to x.com, you actually get redirected to a place called twitter.com. So we all use Twitter. I don't know what this X thing, okay? I don't know what this whole X thing you keep talking about, okay? I don't know what it is. You guys keep telling me about X and that I keep using it wrong, yet I keep going to twitter.com. I don't understand why you guys keep telling me this, okay? I know X is going to give it to you, just hasn't given it to me yet, okay? I haven't got it yet. I'm waiting for it. All right. Anyways, okay, we see that it just gets worse. Obviously, we see that async hooks add significant amounts of latency. I mean, it's no different than, like, say, for each for an array. For each obviously adds latency or adds processing in comparison to a for loop. Totally reasonable, right? Does this article discuss resource pooling? No, they don't do any of that because it's not about that. It's just about promises, which I think is really great. This is a great topic, by the way. Data loaded, no async hooks. Data loaded with async hooks. Whew. Whew. Async hooks overhead, log scale. Whew. Yeah, I mean, it makes sense that... Whew. We roughly see that async hooks roughly adds 3 to 3.5x overhead to resolvers. Datadog engineers are diligently working to reduce this overhead by contributing to Node.js and V8 features. However, improvements in this area are critical to get right and take time to be implemented. In general, we want to reduce the overhead of promises and reduce the number of promises we invoke. Reducing promises overhead to reduce promise overhead, we want to minimize promise inspection of features. Yep. Reducing the number of promises to reduce the number of promises invoked. We have a few areas to consider. We could remove the use of GraphQL middle layer. Let's go. Let's go. Especially the ones that assume every field is async. We could also rewrite GraphQL queries to use fewer async type resolvers. Just rewrite it. Just rewrite it, bro. Fork it. Just fork it. A single resolver that manually queries the database and returns all the data needed for performance-sensitive queries, rather than relying on GraphQL to hydrate nested fields type resolvers. By the way, just rewriting things is difficult. It is difficult. It is very hard to be able to see the problem about easy is that easy is hard. Do you know what I mean? Easy is hard. Easy is truly hard. And so this is like GraphQL gives you the promise of easy. I know, I see the pinned message, fine. Omega lol, Omega lol. Twitter, the Facebook. Same energy? If it's the same energy, why does x.com take me to twitter.com? Okay? What am I supposed to call it? I can't read. Did you put a spelling joke in there? You know I can't read. You know I literally can't read. Okay? You know I literally cannot read. All right. What kind of joke is that? Oh, I'm making fun of Prime for not being able to read. What a loser. Can't even read. What a loser. Thanks. I guess dyslexia is a cool thing you can make fun of now. You know, out of all... Gosh, I should be able to say... Okay, DJ, I'm going to quit saying I have dyslexia and that I'm neurodivergent. And then guess what? When you make fun of me, you're making fun of neurodivergence, and that is pretty offensive, TJ. I mean, that's... I would say we're probably in cancel territory. Disgusting. Absolutely disgusting. Shook. Hashtag not a safe space. American education, Kekona. I can't read Kekona. Can't even blame him. Kekona. Kekona. See, I'm making fun of the U.S. It's okay. Okay, you're lucky. You did get by making fun of the U.S. So we could write a one-shot resolver that implements the entire query. Okay. Wait, find user by ID. Dude, I'm just so triggered by this. I am literally so triggered by this chatty protocol. Find item details. I am so effing triggered. Why do you gotta do this? Return all the items. Items map. Const details. Find. You create. Okay, so I'm gonna say something completely different. I want you just to look at this for a second. Okay, I want you to look at this and you want to ask yourself why does my endpoint have so many large latency spikes? Why am I garbage collecting all the time? Let me just, like, regardless of the fact that you're doing 2 queries like this, let's just talk about something different. First off, an await. Obviously causing a promise, which causes multiple callbacks, which cause a whole chain thing to be set up, blah, 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 blah. Inefficient, causes memory. Do it again, causes memory. You also create an object right here. Not only do you create an object, you also have an array. You copy the array. Boom. Okay, so you create an object and an array, and you create a closure, and you create a Lambda function. Okay, you create 4 pieces of things that have to be cleaned up. After that, you return an object. Okay, you return an object. Inside this object, you do yet another map over items. Okay, so now you're at 7 objects. In here, we're going to do a find. A find creates 2 more. Yay! Then you're going to return an object that has an inner object that creates the details by ID, and then, which literally is details by ID. I want you to look at this. It's details by ID, and then creates another copy of the details. You copy the details. It's like 12, 15 pieces of memory. So every single time that's called, something has to go and like collect all this, right? There's so much going on here. This is massively, it's just like a lot. This is a lot of memory. This is why I get triggered so easy by JavaScript, because it's so easy to create memory. It's so easy. Like, it's so easy. You could just do it. You could just create it all day on accident. And then garbage collection is wild. It's like 15% of your application. If you're on a single core machine, it could be well over 15%. Instead of multiple batches of promises, we fetch the user items and details in one shot. That brings up the meta question, why use GraphQL in the first place? But that's for a larger conversation for a separate time. Okay. Anyways, I do agree with the whole GraphQL. Do you really need GraphQL? What are you buying out of GraphQL? I understand the benefits of GraphQL. I did literally write Falcor. I still think parts of Falcor are a good idea to this day, but I also see the downsides of this, the easiness to create chatty queries, the fact that we're looking at 2 select things that clearly should be 1, right? Like, you see all these things that end up happening. When you break up your API into these really fundamental small little pieces, you could always accidentally create hyper chatty protocols. And this is a great example of those hyper chatty protocols. And so it's emotional. It's emotional, right? But I love the point of this article, which is promises are, they cause so much more overhead. I really wish this article would have went over this, because I didn't do a really great job. I didn't do a lot of justice here on this, but this is really good to think about, is that whenever you do something and anytime you resolve, you go to the back of the line. So if you have 15 requests per second, then you are literally potentially sitting behind 15 requests every single time you do a promise, right? It could be really hard. It could be a lot, depending on how many queries are, how many things are running at that time, how many promises are running. Internally, if you do a promise.all, you still have all those being added to the queue, right? So it's not just a singular promise. A promise.all could have you do it a bunch of little times as well. Anyways, just something to think about. The name! I really wish I didn't concern myself so much with memory, but it's an emotional, bruising situation and sensitive topic, okay? A Jen.